My name is Fabian Hüftle. I'm working in an engineering office with focus on emission assessment and environmental consulting. And today I will show some case studies we did in cooperation with Olfasense about odor impact from wastewater treatment and inner city restaurants with charcoal grills. And case one is about the residential developments being built close to established odor emitting wastewater treatment plants. And case two is about the restaurants with charcoal grills emerging in vibrant city centers. Both cases creates tension between urban planning goals, environmental quality, and here the key objectives are the prioritizing densification within city limits to make optimal use of inner land rather than expanding outward, and also to ensure the operational viability of wastewater treatment plants. For the restaurants and city centers, it's very important to safeguard the lively urban lifestyle with the emerging vibrant gastronomy by avoiding the significant odor nuisance in line with the German Federal Emission Control Act. And in this context, also these guidelines values were serve as a reference. They focus on the relative frequency of odor hours per year as an indicator of acceptable impact levels. And especially for urban housing, there is a threshold of odor impact with 10% odor hours a year. Let's start with the wastewater treatment. The wastewater treatment is established in this case, for more than 100 years on this site and located in a large city with more than 500,000 inhabitants. And on the left, you can see the schematic map with the wastewater treatment sites and its surrounding area. And on the right, the prevailing wind directions. As you can see, the planned residential area is exposed to odor emissions because of the winds coming from east and west from the treatment sites. So from both treatment sites, the emissions goes very strongly to this planned area. And at these wastewater treatment sites, we face a complex emission scenario, including passive and active area sources, diffuse sources from material handlings, and point sources such as stack emissions. And we need to estimate odor exposure as precisely as possible for the investors of the residential area. We divided the project as a workflow in two parts. In phase one, we started with on-site assessment at 2 wastewater treatment plants to identify the odor sources and define the impact zones. And the measurements take place over 3 years. So we ran several measurement campaigns under different boundary conditions because the sources have different conditions if it's hot and dry in the summertime or maybe in autumn or winter time. And then we used the dispersion modeling to estimate the odor impacts. And our first results showed odor levels above the threshold in the planning area. So we have to move to phase 2 and validated especially the area sources with blue measurements and used inverse calculations for source location and the emission rates. And this led to new measurements of the area sources with different hood ventilation setups on the site. So especially for covering active surfaces exposed to air movement and biological activity, we have a hood ventilation about 30 cubic meters per square meter and hour. And for passive surfaces with no active aeration, then we was hood ventilation is 15 cubic meters and square meters per hour was used. And then we had also subsurface sources where we reduced the hood ventilations to 2 cubic meters per square meter. And additionally to this, also on the plant side, there was some air treatment at the point sources. And this air treatments achieved a reduction of 80% in the measured emission. So we adjusted also, so at this, in conclusion, we adjusted these emissions and updated our dispersion modeling that the results showed that the results meets all planning requirements, balancing operational needs of the wastewater treatment plant and environmental quality on the housing side. In this case, we ran different multiple scenarios with the dispersion model, including different conditions and potential mitigation measures. And the aim was to understand the odor impact under a range of realistic situations and to test how various interventions could reduce the emissions. What we're showing here is a no action scenario from phase 1. And with no action, the estimated frequency of odor hours reached 15% in the planned housing area, but also you can see the surroundings areas are very have a very high impact of odor emissions. So after we validated the sources and adjusted the models and assessed the effectiveness of the mitigation measures, finally the impact in the planning area was reduced to a threshold of 12% odor hours per year in a little area. So the complete housing area is now the estimated odor impact is now almost impact with very low impact or no impact at all. Then our case 2 is about exposure in urban areas caused by restaurants using charcoal grill. So this is a new restaurant kind of restaurants coming up in the cities, and there have been complaints in over 180 cities in Germany about smoke and odor from grill restaurants. Surprisingly, only about 15% of them have exhaust treatment systems. So most emissions go directly into the urban environment. These restaurants operate between 4 and 12 hours a day and being mostly located in dense city centers, so the smoke and odor have very little space to disperse. Especially even when the chimneys extend near to the roof ridge, the exhaust is released within the urban boundary layer, limiting the dispersion and increasing local impacts. The pollution release includes especially odor, NOx, CO, particulate matter, and the PAHs from the incomplete combustion of fats and oily marinades. But maybe you can't believe this, but currently in Germany has no general regulations for the commercial charcoal grill, so emissions are largely uncontrolled. And so we have to face these problems. We focused in this site on 5 charcoal grills. They are located near dense inner city housing in a city of over 1 million people, and the area is a mixed-use neighborhood with residence services and other restaurants, so a lively city center. And the nearby residents have reported complaints about smoke and odor. Our goals were to assess the current odor exposure, analyze each restaurant as a separate source, and identify possible measures to reduce the impacts. We conducted on-site measurements using a mobile lab combining sampling and olfactometry. And during the measurements, we recorded volumetric flow, exhaust temperature, humidity, and ensured that the grills were at preheated, full-loaded conditions. Each grilling process lasts about 8 till 10 minutes, and during which we collected 3 short samples and 1 30-minute sample to capture the full emission profile. And this approach allowed us to quantify odor emissions and evaluate potential strategies for mitigation. The range of the measured odor concentration during peak operation was between 9,500 and 28,000 odor units per cubic meter. And this shows the significant difference between measured odor concentrations from charcoal grills and the regulatory emission limit of just 500 odor units per cubic meter for most installation according to the German TH Luft regulations. And this is highlighting the need of an effective emission reduction measure in the urban areas. the selection of flow and dispersion method. Due to the complex urban structure, we used the prognostic microscale wind field model, in this case MISCAM, together with the Eulerian dispersion model based on site-specific meteorological conditions. And the analysis was made in two highs because we also have to make an explain how the water exposure is in around 80 meters above the ground level, because there are some residential apartments that are directly under the chimneys from the restaurant. So this was very interested because there are some residents they have directly they are directly infected by this smoke and odor impact. The results in this case, as an example, let's have a look on the odor emissions from one single charcoal restaurant. On the left, you can see that even one grill exposes the surrounding area in a distance up to 150 meters to odor well over 10% of odor hours a year. And imagine with all 5 grill operating, odor will occur for significantly more than 20% of the year. So this is a real problem in the city centers. And to this on the right, according to a manufacturer of cleaning systems, we reduced emissions up to 95%, resulting in a satisfactory outcome. But to achieve this reduction, a multi-stage exhaust cleaning system is required along with a regular maintenance schedule. So it starts with you have to use an aerosol filter to remove fine aerosols, and pre-filter captures then the large particles, and you need an electrostatic precipitator that captures very fine particles and smoke. After that, you need an after filter to ensure clean air is released, and then the complete air goes into the UVC unit with a reaction chamber that breaks down the odors and the organic compounds. And in the end, you need also an activated carbon filter that absorbs the remaining odor or gaseous pollutants. So this is quite an effort for this kind of little restaurants. There's also a big investment for them. So there was thinkings about what can they change maybe in their process, but they were not agreed with modify the cooling procedure or to switch to gas-fired operations to reduce the smoke from the charcoal. So also the alternative option to raising the chimneys was impractical because of the varying roof heights and the urban boundary layer. So this was these two case studies, and this demonstrates how we can tackle this challenge through technical solutions and thoughtful planning, and especially an integrated approach with measurement, modeling, and on-site validations will get you a reliable odor prediction. And effective mitigations may enable more valuable land use close to odor sources, especially like in the case of the wastewater treatment. And our model limits have that odor intensity and hedonic tone is not considered, but it is also not considered under the German Luft regulation. So we only have these kind of odor hours per year as a threshold. And this emission threshold of 10% is standard for the residential areas. Our experience is that also local adjustment of this threshold is maybe justified, especially if you're considering local customary odor levels. So in the end, thanks for your attention, and yeah, if you have questions.
Many thanks, Fabian. We are almost in time. Let me check if from YouTube is there any question. It does not seem so. Just a very quick question by me. Maybe if it would be possible, we will be glad to have you also for the round table in the late morning. It was not clear to me. I've seen that you have used a microscale dispersion model for the restaurant emission, but you have used the same model also for the wastewater treatment plants evaluations?
Oh no, for the wastewater, we used the mesoscale model Austal.
Austal, okay.
Because the sources were different. In the city center, we have high buildings, and the microscale problem for the. Yeah.
I see. I only have seen that also in the wastewater treatment plants there were the buildings plotted as receptors, so maybe you consider this, but clear to me that in that case, not being directly in a urban microscale situation, it would have been too much to use a microscale.
Mm-hmm.
So still from YouTube, no question is coming. So many thanks, Fabian.